video, we're going to explore centre of mass and its effect on buildings. So have a look at this footage of one of the Japanese skylines during an earthquake. Now, at the moment the phone is actually shaking, so we've taken away the shaking movement. And if you look closely at the buildings, especially the glass building that you can see in the middle of your picture, you can see it moving. Now, all buildings need to have the ability to move. The materials that make them up need to have the ability to sway from side to side. Here's some footage of two skyscrapers from high up, and basically as we zoom in you'll be able to see that swaying movement. Now this swaying may be required due to the movement of the land, or also due to the give of wind. Now in all of this case, the centre of mass has to stay between the footings of the building. The centre of mass goes further than the baseline, then the result can be catastrophic, i.e. the building can begin to collapse. Now what we've got here coming up in a second is a computer simulation of the building swaying, exaggerated by 20 times. So you can see it swaying from side to side. Now what happens if it goes wrong? Well, here's some footage from the Philippines. Now what you can see here is the building falling, and the centre of mass goes over the baseline until eventually, that's it, the building crashes. But how does this happen? So what we've done is gone back into the lab to demonstrate what's going on. The block here is our building, and then we've got a line with a mass on it showing our centre of mass. Now it's portioned through the centre of the buildings. We've got some tape there which basically is going to prevent the building from sliding. So what we're going to do is raise the platform. Now this is going to be the effect of moving the centre of mass. So you can see that the centre of mass is moving and basically is moving to the left, and eventually the centre of mass comes over the base of the building. So you can see as that centre of mass moves, eventually what we'll get is to a point where it'll be beyond the base of the building. The result of that is the building will begin to topple and slip, and the result is it will crash. Now this is quite a heavy block, so as a result we can have quite a lot of movement. So keeping something squat is actually a good idea. But what happens if we increase it and have a taller object? So we've got the same scenario with a block of wood. We've got our centre of mass acting through the centre. Our tape is going to prevent it from slipping, and we're going to lift the board. Now you will see quite clearly that with just a small amount of movement we're going to get the centre of mass to move over the base, and the result is the whole building will topple over and crash. Okay, well I hope that's explained centre of mass. Thank you for watching.